Hi, Hike and Jim here. Welcome to another episode of Adventures in Stoving. We've got two stoves here. On the left we've got a Monatauk Gnat, and on the right we've got a Soto Microregulator OD1R. And it's kind of cold out. I'm at approximately 6,000 feet in the San Gabriel Mountains, and I think you can probably see there's snow around me. And anyway, I'm just kind of curious if I can tell any difference in the way a microregulator handles cold and the Monatauk Gnat handles cold. So I'm going to try firing them both up, and these are identical tanks of fuel, and I'm going to see if I can tell any difference between the way the one handles the temperature right now and the other. Now, what I've done is I have opened both valves full, and I'm just taking a look here and seeing what I'm seeing. And just from the start, the microregulator has a much bigger flame, and I noticed the Monatauk Gnat is getting kind of orange. That's kind of curious. So let's see, though. I mean, the thing is, when you run a gas stove, both flames are still okay size. It looks like they're both a little smaller maybe now when I started. I'll have to look at the video when I play it back. But, you know, the thing that happens with tanks of compressed gas, when you compress them, they turn to liquid. And then when you release, open the valve, when you release the pressure, they turn back to gas. Unfortunately, it takes heat to turn them back to gas. And so that heat has to come from the environment. And I don't know if you can see, I've got a piece of closed cell foam on top of this snow-covered rock that I'm doing the test on. So that heat's got to come from somewhere to vaporize the fuel, to take it from liquid form to gas form. And so there's not a lot of heat available when the temperature is such that you've got snow on the ground. And I don't know the exact temperature right now, but chilly. And so I'm just trying to see if there's any difference in the way the two stoves handle it. Both of these tanks are tanks that once held isobutane propane mixes. They now hold 100% butane. I do my own refilling, so they both hold 100% butane. They've been refilled from the little, I don't know what you'd call them. There's a square stove that has a bayonet connector type canister. It's a long cylindrical canister. Now, both stoves are showing markedly decreased flame. The Soto still has a little bit larger flame, maybe, but both stoves are showing definite decreases in flame size. And so I can see that the cold is affecting them. So I'm just going to let the burn continue here. This is probably very exciting for all my viewers at home. This is about as exciting as watching paint peel, but we can see two stoves and two flames, and they're both gradually diminishing. So anyway, the point being, though, is that what's the cold going to do to a stove, and how is it going to affect the flame, and is the microregulator going to make any difference? Compared to the initial size of both flames, both seem to have diminished significantly. I don't see the microregulator coping with the temperature all that much different. Let me pull out the thermometer here. Okay, so my thermometer is saying 31 degrees Fahrenheit. So this is a digital thermometer. I have no idea how exactly accurate it is, but it feels about that cold, maybe slightly colder. Now, okay, as the burn continues, I'm just seeing the flames continue to diminish here. Again, the Monatauk Gnats looked a little smaller even when I've opened both valves to the max. So the Monatauk Gnat is definitely a smaller flame right now, but it was smaller even to start. So that could just be the way that the stove is designed. It could be that the jet is a little bit smaller aperture than on a Soto Microregulator. But both have clearly got a much smaller flame. If you play back the video at all, you'll see that they both had a much larger flame. I mean, the Soto Microregulator has quite a large flame when it first is started up. So now I started the Monatauk Gnat just slightly earlier, so maybe there's a little disadvantage there for the Monatauk Gnat. Monatauk Gnat is just kind of struggling. Both these tanks don't have a lot of fuel in them, so it could be that we'll go to burnout on them. Both of these flames right now I would call fairly weak. They're both still going, though. They're not running out. But the thing I see, though, is the microregulator, boy, it's, I don't know. I don't see that microregulator making a huge, enormous difference. I mean, in terms of proportion to initial starting size, both of the flames seem to have diminished quite a bit. So I don't see that the microregulator is able to compensate for the cold. I think part of the issue, of course, is that the microregulator can only regulate if there's additional pressure. You can't, I mean, you can open up a valve only so far. If there's no more pressure to come out, then opening the valve up further through the regulator isn't going to increase the flow of gas because there just isn't any more pressure in the tank. So as I'm looking here, I see that both are getting pretty small. The wind is affecting them, of course, a little bit. It's not super windy, but you can see both flames are pulling to the left of the frame. Well, I'm just going to let the video roll for another minute here and see what happens. You know, this is pretty typical of stoves of this type in this kind of temperature, that you know, the flame just isn't the normal size and shape. If I took some hot water right now and poured it onto the stoves, I'm sure they'd flare right back up, as they typically do. That's the old trick, is if you're in cold weather. The first bit of gas, you heat up some water, and then you put it in a pan or a bowl or something, and then put it underneath the tank, and put the tank in the warm water, not hot water. That could cause a flare-up, and that would be really dangerous. But if you put it in warm water, then it'll cause both stoves to, or either stove, any stove, to operate more at a higher level of output, because you'll have better gas flow as the water allows the gas to vaporize better, the heat from the water. So I see some flickering in the flame on the Soto Microregulator. Both stoves are looking kind of weak here, so if it was at all windy or a little colder, I bet you'd have trouble. These are like almost simmering flames rather than boiling flames. Well, there the microregulator kicked up a little bit. Well, all I can see is that I'm getting a really weak flame. It's interesting to me that at 31 degrees, since these tanks both contain butane, that they're working at all, since it should be just really insipid. Both of the tanks were in my backpack, so there may be some heat in the tank. They may not quite be at air temperature, although as the gas escapes, it should bring them down. I guess I could touch the tanks and feel the tanks and see how cold they are, but my fingers are kind of cold right now. So I'm not really sure if I can tell how cold the tanks are, and it's a fairly subjective measure anyway. Well, all right, this is pretty exciting, just watching the tanks go down. Now, the Soto Microregulator took a little dip there, but that might have just been the wind. But anyway, I guess the point is I'm not seeing a lot of difference between the microregulator and the Monatauk Gnat. The Monatauk Gnat's a conventional needle valve type stove, and the microregulator is a regulator valve type stove. So I'm not seeing that either one has a particular advantage over the other in terms of handling cold weather. Both have rather low flames right now. Maybe the microregulator has a slightly bigger flame, but again, it started with a bigger flame, so that could just be that it just has a bigger flame, period. It's not able at all to maintain its flame size as the burn continues. Well, I don't know if you guys can handle it. Here we are, nearly 12 minutes of edge of the seat excitement, watching butane burn. Yeah, hiking Jim, you sure know how to live. But you know, both stoves really, to me, have roughly similar flames. I don't see a marked difference in the way the microregulator handles the cold weather. You know, so in fact, maybe the microregulator's flame actually shrank more because the microregulator had quite a large flame at the start of the burn. I guess I could just sit here and let it burn for some more. I'm still actually impressed that it's burning at all, since it's about 31 on the little thermometer I've got. And that thermometer, I don't know, who knows how accurate it is, but butane boils at 31 degrees, so you're not going to get... you need to have a certain amount of temperature differential in order to get good pressure. You want to have about 10 degrees difference between the boiling point of the fuel and the actual air temperature. So, well, actually, not so much the air temperature, but the pressure, the tank temperature. The temperature inside the fuel tank needs to be about 10 degrees above the boiling point to have a really good pressure to have normal flame volume in your stove. I'm impressed that as long as we've run this, as long as I've run this entirely boring video, I'll stop it at 15 minutes no matter what, which is about only 1 minute away. But anyway, I'm surprised that given that it's quite chilly out and that these stoves have both been running for, now I didn't start them immediately when I started the video, but these stoves have both been running for over 10 minutes at least. And so I'm surprised they're running at all, since the tank temperature is approximately equal to the, at the start, approximately equal to the boiling point of the fuel inside. And the other issue, of course, is that as you release the gas, the temperature is going to decrease. So the tank should now be lower than the ambient temperature. Maybe I'll get that crazy thermometer out. All right, too much excitement for one day here. Just gonna see what this tank, if it gives me any reading here. It's getting kind of dark too. All right, now I've got, the temperatures are still dropping a little bit, but I've got 28.6 degrees, 28.5 degrees Fahrenheit. It's slowly, well, there we go, 28.5, 28.4 on that tank. It's probably about the same here on this tank. That's Fahrenheit degrees, of course. Oh, now that's interesting. This tank is warmer. This tank is 30 degrees. The tank, and it's rising still, 31. There may be some heat feedback from the Monatauk. That's very interesting. The Monatauk is a titanium stove. You wouldn't expect a lot of heat feedback from a titanium stove, but there could be some heat feedback through the column. And I've got on the tank temperature 32.5 degrees, still climbing, just very slowly climbing. Now, well, 32.4. Okay, now it's going to 30. Well, it's wavering a little bit here. Maybe I'm getting some flame feedback. 32. Now let's go back over here. Yeah, the temperature definitely came back down again a little bit. Now I'm down at 30, 29, 29.8. So there may be a little minor, not much, heat feedback through the Monatauk Gnat. But anyway, both of these stoves are really weak flames right now. Neither of them is what I would consider an appropriate flame for cooking on. The Soto Microregulator is getting kind of yellow. The Monatauk Gnat is just downright insipid. I'm going to go ahead 17 minutes of video. This is a really exciting video. Yeah, I know. Living large here with Hike and Jim. But anyway, it's just interesting to me to see. There's all this talk about how the microregulator is going to handle cold better, and I'm not seeing it, honestly. The flames look markedly similar to me in these two tanks of 100% butane. Okay, well, I'm Hike and Jim. This is another episode of Adventures in Stoving. Maybe this episode's a little less adventurous than some other ones.